Hi everyone, so today we're going to talk about different healing strategies, so with wounds and burns for our integumentary system. So starting here, we see we're going to talk about wounds. So we see what our normal skin looks like. We can see we have our hair follicle, our glands here, and our epidermis all intact. But when we have an injured, we see a chunk of that is going to be missing. So what we're going to start to see is that since we have severed blood vessels here, we're going to see blood start pouring into our area that is injured, so our site of injury here. And we see that it went straight through our epidermis and into our dermis here. So what's going to happen is that blood is going to escape into this cavity right here where the injury occurred. So blood escapes into from our dermal blood vessels. Next, we're going to see our blood clot. So clotting factors are something that's going to be really important in our skin and in all our blood. So what those clotting factors do is they stick together to form this blood clot. And this blood clot is going to keep anything else from coming into the wound. So after we have our blood clot, we're going to see that it starts drying, and you're going to see this tissue under here is going to start to reform and repair itself. But our dried blood clot is going to form a scab. So our scab is made of our blood clot and dried tissue. So once it starts to scab over, we're going to see that blood vessels are going to start to rebuild under here, and fibroblasts are going to migrate to our area here so we can start building new fibers. So what's going to happen? Blood vessels send out branches and fibroblasts migrate to that area to rebuild tissue. So they're going to produce, our fibroblasts here are going to produce new connective tissue fibers underneath our skin. Something else that we're going to see is that our scab is going to fall off here, and we're going to have scar tissue on the top of our epidermis over here. So with scar tissue, some injuries are going to scar whilst others won't. So if you just scrape your knee, you're probably not going to see a scar, but scars usually form when we see really deep cuts that heal a lot faster than the skin can reproduce, which is going to cause this scar tissue to form here. So scar occurs, like I said, when there's extensive damage, and it's mostly going to be composed of collagenous fibers. So that's going to be important for wounds that we're going to see here. Next thing we're going to talk about is burns. So part of burns is sunburns, which is one of our least degree burns here. But something we are going to talk about is SPF, so sun protection factor. So SPF is a measure of how long you can stay exposed to the sun without burning. So if we're looking at a bottle, and if you begin to burn or tan after 10 minutes, SPF is going to extend your protection. So if we have an SPF of 15, it's going to extend your protection for 15 times what it normally would. So what that's going to mean, if you burn or tan after 10 minutes, we're going to multiply 10 by that number, and we get 150 minutes of time that we can be exposed to the sun without burning. So say if this was 30, so if we had an SPF of 30, we're going to multiply that by 10, we would have 300 minutes of time that we are exposed to the sun without burning. So if we look here, sunscreen is going to be a little bit different. So sunscreen is going to absorb UV rays and decrease our level of penetration, where sunblock is going to reflect our UV rays. So there's a little bit of a difference here between sunscreen and sunblock. So remember, sunscreen absorbs and sunblock reflects. So let's talk a little bit about different types of burns that you can get. So our first-degree burn, our skin is warm and red, and it's our mildest form. So as the numbers increase, we're going to see a more severe burn. There are no blisters that occur with first-degree burns, and healing usually takes within a few days or to 2 weeks, and there's going to be no scarring as a result of it. A good example of this is a sunburn. Our next type of burn is a second-degree burn. So remember, we're getting progressively worse here. So there's an appearance of blisters, which means there's a loss of fluid from our cells. There is damage that extends through the outer layer of the skin into our dermis. So it extends through the epidermis into the dermis. The injured region becomes moist and firm and might vary in color from dark red to a waxy white. So that would be our second-degree burns. Keep going here, we're going to see that our skin usually recovers and scar tissue does not develop unless there's an infection of our burn here. So some examples of this would be exposure to hot objects, hot water burning, flames, or burning of clothing. Third-degree burn, as we're moving up here. This is our most severe that we're going to see. So the burn has damaged the epidermis and dermis and the accessory organs of our skin. So the injury becomes dry and leathery in appearance, and it's going to vary in color. So we can see anything from red, black, to white. So some ways to treat this: an autograft is removing skin from another area of the body and replacing it onto our burned area to help heal this process. A homograft is a transplant of skin from a cadaver, which is a person who has died and donated their body to science. And then tissue engineering is another way that we can see to help treat burn victims when they get these third-degree burns, because these are the worst-degree burns. Something that you might have heard of that is very much in testing stages is tilapia skin. Is really helpful with treating burn victims. So the way that you can get these types of third-degree burns is an immersion into hot liquids or prolonged exposure to hot objects, flames, or corrosive chemicals. So these are all different examples of third-degree burns. Remember, our most severe. And when we think of damage to accessory organs, we're going to think of our hair, right? So when we have a very severe third-degree burn, hair is no longer going to grow in those areas of the body. And rules of nines is something that we're going to talk about. So this indicates the extent of the body surface that is affected. So we're going to take a look at that right now. So if we take a look at that image right here, we see that we have different parts that equal 9% of our body. So If we look here, our anterior and posterior of our head and neck is our 9%. Our anterior and posterior upper extremities is going to be 9%. So we can see the front of our arms is 9% and the back of our arms is 9%. The anterior and posterior trunk, so our abdomen over here, is going to be 18%. So that's still an equivalent of 9, but together that makes 36. And then each of our lower extremities is going to be 9%. So one leg is 9%, the other leg is 9% in our anterior, and our posterior, same thing, making another 36%. The last 1% is going to be our peritoneum, which is just 1% there. So we see 9% with our anterior and posterior of our head. We see another 18%, which is 2 9s with our anterior and posterior of our upper extremities. We see 36% with our anterior and posterior trunk. And then we see another 36% with our anterior and posterior of our lower extremities. And all of this is going to equal 100%. But all of these numbers are divisible by 9, which is why we call it the rules of 9. So this is where we're going to stop today. If you have any questions about healing and wounds, make sure you ask.